this computer. Thank you. There it is, creepy robot lady. Thank you. Okay, right. Again, thanks to Scott and Mark for some thoughtful feedback on this slide deck, or a version of this slide deck. So, right, and special thanks to my former colleague at Target, Mahi, who has spent a lot of time with me working some of these ideas out in code. Nobody had really done this stuff in Java, or at least done it and written about it. So we were kind of on our own. Just a quick note that this talk relates primarily to architecture as the internal structure and design of a single application, which is different than the way the word is sometimes used. Architecture typically describes the structure of a broader system. Functional architecture is application architecture, not system architecture. Before we go on, some of you may already be familiar with Spring WebFlux, the rest of you. Don't worry too much. This isn't a talk on WebFlux specifically. In general, I'm attempting to introduce you to concepts of functional architecture within the context of Spring WebFlux. Having said that, here's just a little bit on WebFlux, so you don't get completely confused when it comes up. WebFlux is a functional reactive concurrency framework based on the communicating sequential processes model. And it is, of course, part of the Spring kitchen sink. Oh, right. The heck is concurrent sequential processes, communicating sequential processes? We're definitely not going to get all the way into this, but CSP is just a method of communicating between asynchronous blocks of code. Most of you are probably familiar with threads, which are also asynchronous in Java, which communicate by grabbing a lock on some memory and then reading or writing a value there. With communicating sequential processes, subroutines can send messages back and forth while continuing to run independently. For a much better overview of CSP in general, see Rob Pike. Here he is, and the humble genius behind Go's concurrency model, and the screen cap of his classic talk, concurrency patterns in Go. Again, there'll be a link to this one at the end of the section of the full deck. Rob, he's such a good teacher. I mean, man, I'd love to just spend a weekend with him. All right, it's worth noting that concurrency and parallel processing are two different things. And again, WebFlux is a toolkit for doing things concurrently. Concurrency is a way to organize code in such a way that logically distinct subtasks can be executed independently. We say that our concurrency is non-blocking when we don't wait around for the results before we move on. We evaluate the results or handle the failure of each subroutine separately. WebFlux uses a functional programming paradigms to build these subroutines. In WebFlux's version of communicating sequential processes, the messages we receive from other subroutines come in the form of events. And here is Josh Long doing his thing explaining Spring WebFlux. Good stuff, Josh. Okay, so that was a gross oversimplification of functional reactive programming in WebFlux. If you're brand new to this, you can go back later and watch any video by Josh Long, and there's probably some others out there too. In the meantime, most of what comes next should still make sense to you, regardless of how familiar you are with WebFlux. Okay, on to the main focus of the talk, functional architecture. So what is functional architecture? In a sentence, it's a design methodology that applies the concepts of functional programming to a subset of domain-driven design. We'll be covering just the basics of the components that this methodology is derived from, with the goal of inspiring your curiosity to delve deeper into the topic for yourself. It is not my intention to teach a college-level class on any of these concepts. There's one click behind. So, expectations set. We'll also demonstrate some of the ways in which functional architecture can make code bases better and more maintainable. We've all heard these promises before. about other methodologies, but I really think that the way functional architecture delivers them is particularly interesting. It should also become clear that functional architecture contributes in some other important ways, particularly when it comes to reasoning about concurrency. Just going to give you a second to look at this. Good, this is important. It might be helpful to tell you at this point a quick story about how I fell into functional architecture. When I and my team at the time were making our first attempts to build an application that was reactive from end to end, we came to realize there was an impedance mismatch between Spring's MVC model and the layered model and the functional paradigm of Spring WebFlux. Here's an example of some glue code that actually came up while developing one of the examples we'll look at in the second half of this presentation. After a while, researching a bunch of different methodologies or approaches, I discovered the existence of functional architecture, which completely, no joke, changed my approach to writing software after 20+ years. If you get a chance, I strongly recommend this up for yourselves. Again, links at the end. Let's look at what problems functional architecture is trying to solve. For a long time, end-tiered architecture has been an effective strategy, basically the default for building applications. The browser talks to the controller calls services, services talk to APIs and resources, then the entire call stack unrolls to eventually return a result to the controller, which eventually passes that back to the caller. Maintaining a clean separation of these layers for the duration of an entire API call requires a little discipline. The call graph may end up involving many related services. And without sufficient vigilance, it can grow to something like this, where you have services calling services and circular dependencies and all that stuff that anybody who's worked with Spring for a while should be familiar with. This is all compounded when we introduce reactive streams and asynchronous programming. There's an architecture diagram of that. Now we've looked at some of the problems it's trying to solve. Let's go back and look at what functional architecture actually is. Remember, it's a design methodology that applies the concepts of functional programming to a subset of domain-driven design. Let's take a look at each of these components one at a time and see what the center of this diagram really means. Some of you may know some of what comes next, but hopefully you haven't seen it arranged in this particular way. If you have, cool. Let's talk a little bit about functional programming, and I mean just a little. I'm not by any means an expert in functional programming. I do, however, have decades of experience writing functions. Some of that applying bits and pieces of functional programming theory. It's important to keep ourselves humble when moving between paradigms. Let's take a look at a brief overview of functional programming as it relates to functional architecture. One of the guiding principles of functional programming is that every function, given the same data, should, whenever possible, return the same result. To do that, we follow some basic practices. If a function changes data, it should return a new copy of that data with the changes and leave the original intact. Validation rules, access control, formatting engines, and the like don't have any side effects. Functions that affect the outside world, such as saving to the database, fetching data from an API, or even opening a cache drawer, should be cleanly separated. That's sort of the whenever possible I talked about earlier. So, but anyway, you'll often see these written as PO and IO in text. The O in PO and IO stands for operation, but it's generally pronounced function. The important thing to remember is IO doesn't necessarily mean input output, but just code with side effects. Higher order functions are an important tool in implementing code that separates impure functions from pure functions. A higher order function is one that accepts a parameter, returns a function, one that accepts a function as a parameter, returns a function, or both. I'm not sure if that last example would compile, but you get the point. I'm introducing this concept now, so you have a couple of minutes to think about it before we come back to it in a few slides. Hopefully some of this will be review for some of you. All right, in functional programming, logic is arranged in a linear flow of functions to transform the data or act on instructions until the desired result is outputted at the end. We're setting aside branching and recursive operations for the moment for simplicity. If we have a stack of functions calling functions with a clear input channel and a clear output channel, we call them function pipelines. It's still possible to write spaghetti code in functional programming, but with a little discipline, I found that it's actually easier to avoid than create. In general, don't write function pipelines that look like this. Many of you have already written function pipelines. They aren't a new concept to Java. Still others of you have written function pipelines using Java's functional programming toolkits. Excellent. You can help people around you when you start implementing this stuff. So that's functional programming, pretty much all of it. Got it? All right, let's take a look at domain-driven design. Domain-driven design is a software design methodology that covers everything from requirements gathering to architecture and design. Obviously, it's too big for one slide, but what we need to know right now is domain-driven design defines an application's boundaries based on the tasks its users wish to perform and the language used to describe them. For example, the word invoice might mean different things, very different things to an accountant than it does to a shipping and tracking application user, even though they may both be referring to the same transaction. We call these language functionality groupings bounded contexts. In functional architecture, as in domain-driven design, we design an application or module for each bounded context. Every aspect of software design is influenced by the question of what do we want to do, in contrast with layer cake's approach of which typically centers around what resources do we need to modify or access in order to accomplish a task. In functional architecture, we refer to these tasks as workflows. In the language of requirements and design, workflows generally map pretty closely to how we use the term use case, although there are some differences we're going to set aside for today. Workflows are the atomic unit of application design in functional architecture. They define the beginning and ending of a series of operations that might involve multiple resources, execution of business logic, and most often some sort of result or external action. Sorry if you've recently bought a house and this is difficult to see. As you might have guessed, the concept of a workflow also maps nearly perfectly with that of a function pipeline. Each workflow can generally be written as a single function pipeline. An application specification that defines a bounded context is made up of a collection of workflows. We can therefore assemble an entire application in code as a collection of function pipelines or workflows. And that's most of what we need to know about domain-driven design for the moment. Before we move on to the part where we put those components all together, functional programming and domain-driven design, I want to take a short side trip, talk about events, because it comes up in WebFlux quite a bit. Each workflow exists within a bounded context, and when multiple bounded contexts need to communicate, they generally do so using events. Some of you are already doing this using messaging systems and queues, right? Functional architecture has some interesting things to say about how to do that. There's a lot we could talk about in this slide, probably a whole separate talk. But for the moment, I'd like you to just understand that when you think about implementing communication between contexts, think about patterns like this one, which exist to reduce overall system complexity. There are actually whole websites dedicated to the various patterns you could use to communicate between bounded contexts. Within REST applications, within REST HTTP applications, Spring WebFlux can, in a sense, be thought of as converting a synchronous API call into a pair of asynchronous request-response queues or event streams, which end up getting tied together later. When we reframe our understanding of REST this way, it becomes natural to model the application logic in workflows. So you can build up your whole API catalog as a set of workflows. We'll see what that looks like. In the context of microservices, HTTP might not end up being the right choice, but however you end up doing it, again, if you end up using MQ or Kafka or something, SQS, WebFlux has probably got you covered there too. Cool. So let's start putting some of these ingredients together. We'll start with how we can separate impure functions from pure functions. Remember those? Using functional architecture workflows in the real world of software products that people actually use. We adapt a paradigm called onion-oriented architecture, which some of you may know as hexagonal architecture or slots and signals or some other name. It's not new, it's been around a while. We adapt this to functional programming. In functional architecture, impure functions are the first and last things that an application does within a given workflow. Business logic implemented in pure functions lies at the center. A unit test in functional architecture should cover all the branches at the center of this onion, and all the I/O at the edges, as you'll see, becomes pretty easy to mock. How does this work? How do we keep pure functions separate from impure functions and still get things done? The essential ingredient is higher order functions, the ones we talked about a little while ago. Remember, those higher order functions are functions that either take a function as an argument or return a function or both. In practice, we apply this idea to separate out pure functions from impure functions. Let's look at a part of an example, the request PTO workflow. It handles the request, recording, and validation of a time off request. If the system detects a conflict within the on-call rotation, the call is rejected. In order to keep the business logic pure, we can separate out the database calls from the actual validation logic by passing in a function that knows how to look up paid time off in the database or from an external service, rather than injecting a reference to that service, for example. That way, the business logic can call that function naively without knowing anything about the underlying implementation, or more importantly, what resources it's accessing. Once we start working with WebFlux monos and the like, you'll see fewer explicit calls to some function.apply, as their invocation is delegated to map and flatmap list. Right away, you can see one of the immediate effects of this style. The impure function can be mocked in line during unit tests. No frameworks required. No before function, no setup, no teardown functions, no in-memory database to keep track of while you have a million creates and deletes to your test database. You can just write a constant function like this guy. Now think about this for a minute though. Is employee not on call really a pure function? Technically, this function is neither pure nor impure. This depends on the implementation. This function is a good example of a concept called isolation. Jessica Kerr talks about this in her talk, Functional Principles in Programming. Mark Seaman references it in his talk, The Pits of Success. Both of these are really, really good. And again, links at the end. A function that has isolation is one whose view of the outside world is entirely dependent on the arguments it's passed. That is, it can be pure or impure depending on what function is passed to it. A pure function always has isolation because by definition, it can't have any side effects. It literally can't know anything about the outside world, including the function that called it, right? So now our higher order functions are not necessarily pure. We do share the property of isolation with pure functions. We can pass in a database call, or we can pass in a constant function, which means that our isolation having higher order functions are equally as testable as truly pure functions. This is the crux, right? This is the model that we're striving for when we have to perform I/O, impure functions within functional architecture. So we've covered a lot of theory with just a little bit of example code. Now let's take a look at what this looks like when we put it into practice. For this demo, we're building a service that allows employees of whatever company to schedule their paid time off. For the sake of simplicity, oh, I'm losing my light overhead here. Sun is just going down out here in the Midwest. I'm in the lovely city of Minneapolis. All right, so some company to schedule their PTO. For the sake of simplicity, we'll assume that this involves 4 steps. First, we need to get the details of the employee from the database. Second, we need to check whether the employee is on call for any part of their PTO request. Our example company uses ServiceNow, so that's probably a REST API call. Next, we check to see if they even have enough PTO. And finally, we save that information to the PTO database. Pretty straightforward. Let's see how we would build this thing using the layer cake approach with WebFlux as the concurrency platform. Right, so got it. We're going to do this with WebFlux using traditional service-based layer cake architecture. This is where it gets messy. A couple of years ago, if I had been asked to build this service, I would have started with an employee service class that was responsible for all the interactions with the employee database. Then added a PTO service to talk to the PTO database, an on-call service to do the on-call thing, et cetera, et cetera. You get the idea. Let's see what that looks like. Here's a WebFlux version of that strategy, which uses the functional programming idioms in an MVC layer cake approach. For this operation, we'd have a method to perform the 4 steps required. Get the record from the employee database, perform validation check to see if they have enough PTO days, check if their PTO clashes with their on-call schedule, see if it all checks out. We save it to the database. This is actually a service call because we'd usually have in layer cake, a separate service responsible for the PTO tables and such. Turns out we also have to do some other things like update the available PTO for the employee. So let's take care of that here too. And then finally we save. Let's take a look at this code block and see what functional architecture might have some opinions about. First, take a look at how the business logic and impure functions are interwoven throughout the code, which makes this somewhat difficult to read, right? The red arrows point to impure functions and the blue ones point to pure functions, more or less. An artifact of this arrangement, you can see us passing a tuple around in order to carry the results of an impure function forward a couple of steps to where it's used. This is really hard to test. And it's even harder to extend with new requirements. We also end up with this nested map, which is usually a code smell in reactive programming. You'll see there's a bug in here. I'll tell you that. Because it's a demo code, it's not supposed to make anybody anyway. Finally, these service classes are often an accumulation of unrelated business tasks, pay stub generation, insurance updates, promotions, all that kind of stuff. Because they all talk about employees, they all live in the employee service. And a reasonable refactoring of this method might actually move the is-on-call function logic over to the ServiceNow service, because ServiceNow service deals with the on-call schedule. The result of this design is that business logics have been scattered across a bunch of service classes, making it hard to follow a single requirement from browser to database and back. When we look at this diagram, the class diagram for this approach, you can see how our business logic for this relatively simple task is spread out across, 3 service classes. For more complex requirements, you probably end up visiting half a dozen or more classes. And here's a reasonable representation of all the different things an employee service might be expected to do. I mean, actually, this is just a sample, isn't it? Just think of all the AutoWire stuff you'd have to mock in order to test just one tiny method of this beast. The constructor alone, right? You'd have 10 parameters. Oh, I thought I took this one out. Here's another example of a service with too many jobs, with at least a couple dozen different use cases living side by side, sometimes within the same method. First clue is that we're importing 4 different repositories, collaborating with 3 other services, right? This is a lot, but it's pretty common. Every one of us has seen a service like this with, 1,500 lines of code. All right, so let's take a look at one possible implementation of this as a functional workflow. Note, I wrote this in Kotlin because Kotlin has a number of constructs that make functional programming a little easier to read, but it's entirely possible to write this same workflow in Java. You'll just have a few more angle brackets. In functional architecture, instead of adding methods to a service class, we begin with a brand new class that expresses our requirements as a workflow, which exports a single function, request paid time off. This workflow has only one job: to orchestrate the execution of IO and PO, impure functions and pure functions, resource execution and business logic, right? Execute all of that in such a way that it satisfies our requirements. This is just a conductor. And as such, it actually reads like a spec. Validate not on call, validate sufficient paid time off, subtract PTO, save, done. In functional architecture, instead of adding methods to a service class, we begin with a brand new, oops, sorry. Let's see. To this effect, you can see that all the required IO dependencies have been injected into this class, right? Let me go back, just make sure I didn't lose anything. Okay, yeah, so we've injected all of our IO dependencies in this class. This is where all the auto-wiring stuff happens. And since it only covers a single requirement, there's only 3 of them. If this class handled like 5 workflows, you'd have 15 or maybe 10, with some optimization. So there's no intermediate, all the IO dependencies have been injected into this class. There's no intermediate service classes, right? We have a repository, and a client. There's no PTO service, employee service. Helper functions would either live within this class or more properly be defined as the function implementations in this same package. This follows one of the principles that I really, really like about functional architecture, which goes that code that evolves together stays together. The inverse of that is true too. We don't put a bunch of unrelated code together just because they talk about the same database table. Okay, so how do we do with our journey through the center of the onion? Remember, in functional architecture, we put the IO at the edges and the business logic at the center. The impure operations, like the database lookups, save operations, happen at the edge of the pipeline. Pretty good. All of the business logic, or pure functions, happens at the center of the onion. These represent the series of operations that actually perform the validation of this task. These express the requirements. These pure functions, this is what the business owner or the project owner wants to talk about. They don't care about this stuff. Let's see. Pure functions in this particular workflow are statically imported functions using some Kotlin niceties. In Java, you typically use a static method reference. Note that the validation function currently returns mono.empty or mono.error. This could be considered a side effect, though it does pass the test of idempotency. It's a hard word, and non-modification of data. So we could just implement them as a filter and do some work to test the validity with a switch on empty or something. But the way that this part is written gives us all the benefits of pure function while allowing us a little more flexibility. Let's look at another example of where we're stretching the definition of pure functions. Here we're passing an impure function as a reference to our pure validation function, right? Validate not on call over here is the business logic, but we're passing in this static method reference, right? That says this is how you get on call. This is a good example of a function with isolation. Remember, functions with isolation are expressed as pure functions, but depending on how they're invoked, can in practice access external resources, in effect, becoming impure. These types of functions are always testable because we can examine the business logic by injecting functions to simulate various external states. Like we can simulate that a user has no paid time off left. We can simulate that there's overlap at the beginning or at the end or at the middle. We can do all of those simulations in pure code. Okay, so let's look at our function with isolation. Here we have an ostensibly pure function, a validation function, the employee not on call method. It needs to know the on-call schedule for the employee, which in our case is a REST call. So in effect, our business logic requires an IO call. We obviously don't want we don't want to dependency inject a REST client into our pure function. Think of the unit tests. You'd have to use mock clients again. But instead, we can call in our new friends higher order functions. Okay, you can see here that the second argument to this function is a function that turns a string into a list of time periods, basically. It's a bunch of angle bracket Java. This allows, it's a function that takes a PTO request and turns it into a list of date ranges, or a string, I guess. I update this slide deck a lot, so you'll see some inconsistencies. This allows our validation rule to be blissfully unaware of the existence of a database at all. No exception handling, no connection locking, none of that. Instead, we just invoke the function and operate on the results, as though we were concatenating strings or adding 2 + 2. This is what I mean by when I talk about separating IO from PO, or functions with isolation. Incidentally, not in the script, but when we talk about this function, which the one that we're passing in calls a database, and I mentioned exception handling, that's really all the database client does. Is it accesses the database, gets the data, and has a really thin bit of logic that says, is this an error? I will throw an exception. That's it. There's no like validation in there. The database, anyway, we can talk about that later. Okay, so that wraps up our little example. But before we go on, let's take a look at our workflow. Talk about how it looks as a class diagram. In general, a workflow class diagram would expand horizontally rather than vertically. The resources that it involves are immediately apparent. If the diagram gets too wide, it might be time to consider splitting that workflow up. We already saw what that looks like in our real world service example with 15 injected things. We'll talk a little bit more about that in the section on best practices, which is mostly Q&A at this point. I've had a few questions on these topics since the first time I gave this talk. Let's go over them briefly. Let's see. Wow, did I not write this? Okay, well, I can talk about it. Decision trees. So like, how do you do if else? You pass in functions. How do you handle errors? You call a workflow that generates a function. But I want to call special attention to the communicating between workflows. We'll go over some more of this in depth in a minute. Give you a couple of guidelines. To borrow a set of guidelines, we'll talk about communicating between workflows, not between bounded contexts, but workflows. To borrow a set of guidelines from software optimization, you might have heard. Thank you, Michael Jackson, not that one, the programmer. Look him up. Be cautious about how you decide to chain workflows. The result is fraught. Not everyone agrees with this, nor with what I'm going to say next. And it may in fact be that I just need more practice at this. But what I found personally is that reasoning about a business case in deeply nested event-driven code is somewhat difficult and can lead to some surprises that take a while to understand. I've gotten, hey, how about that? How do we do if-else trees in our workflows? I thought it'd be useful to add another example here. If you have a significant branch in your workflow orchestration logic, consider using a function that accepts decision data and outputs a function, right? So this is a higher order function that represents an if-else branch. And this is a trivial example that you probably wouldn't use in the real world, but it's close. This is a function that says, are we going to divide these numbers or add them? I guess the goal here is to avoid a divide by 0 or something. If the denominator is 0, we return a function that takes two numbers and sums them. Otherwise, yeah, go ahead and divide them. Right, that's one way. But it's pretty readable though, right? It's not something that's come up a whole lot, but it does come up, and it's a good, elegant way to handle it that stays testable and doesn't create the dreaded arrow code, which can still happen in WebFlux and pipelines. All right. So remember when we talked about workflows calling workflows? Here's one way to do that using a function generator, or a function, as the JDK would call it. Consider how we modify the workflow we just looked at, such that it publishes an error message to a Kafka topic when it catches an error. So here we have, let's see, I'll have that in my other next slide. Yeah, right. The PTO workflow calls a function that you could argue initiates a second workflow, the publish error message to Kafka workflow. It accepts some metadata, in this case, the employee ID, and returns a function that knows what to do with a throwable. So let me go back. So do on error. This is a really terse way of saying this. I should have added this in. There's an implied throwable where it says throwable employee here. Just imagine there's a throwable right here. So you take your throwable and you pass it in to error handler, which then returns the function that knows what to do with the error handler. I mean, with the throwable. It takes a little while to get your head around this. The reason it makes sense here is that it relates to the reason you can call it. Let me back up just a little. Right, here's what I wrote. It accepts the metadata, in this case, the employee ID, and returns the function that knows what to do with the throwable and knows about the ID, right? It knows about the ID that you just passed in. That makes it more or less a closure. I suggest that you ask Venkat Subramaniam about that on YouTube. The reason it makes that sense here to chain these workflows is that the second workflow relates to what we call the generic domain. And that's, again, coming from domain-driven design. And the generic domain talks about all the stuff that like your application touches, as in the server rack or the Kafka queues around it. So we're throwing this out to another generic domain rather than any of our domain-specific contexts. If we're executing logic within our specific founded context, like what? I don't know. doubling the amount of PTO that we asked for, or halving the amount, doing some automated stuff, we might reconsider doing something else. The function catalog or function generator pattern should be familiar to anyone who's used collectors, Java util collectors, especially if you've used a custom collector. Here's an example from JDK's collectors.java that takes the mapping function and returns a collector, which is really a wrapper around a set of MapReduce functions, like a little library of functions, if you will. So these are a lot to take in, but I'm just basically exposing you to the idea that there are a handful of patterns that are useful. And there's a video on functional programming patterns in general. It doesn't necessarily cover these, but you can. The collector implementation defines a handful of function suppliers, at least one of which you supplied yourself as a parameter that a client can execute in sequence. MapReduce. I recommend reading through the source of one of the simpler implementations that's within collections or collectors dot whatever. If you're feeling adventurous, build yourself a custom collector. I've had to do this a couple of times, and it's enlightening, and it's actually kind of fun. And there's some really important use cases for when you need them. There may be only a handful of conditions when you actually want to connect more than workflow. You could build a set of simple event listeners that initiate workflows. So I have this here. What have I got? Okay. That initiate workflows and call them from various points in your workflow. You could just spawn a thread from within the body of your mono.map. You could, and by thread, I mean new WebFlux context. You could compose multi-workflow by joining them together in a wrapper function. These are just ways that you can do it. But you're entering into some perilous territory. Each one of these options comes with its own drawbacks. The pub/sub implementations can cause business logic to fragment all over the place and are notoriously difficult to debug. Mono.subscribe falls silently, leaving the parent workflow ignorant of partially modified data. Meta workflows can simply grow too big and just resemble our old friends, the bloated service. The general idea here is it's almost always better to avoid connecting workflows than it is to try to figure out how to do it. Again, some people disagree with this, and I think take this with a grain of salt. Right. Right now, you might be thinking, this is all great, Jen, but how do we actually use all of this? Great question. Glad you asked. Broadly speaking, we have two ways we can apply this to actual customer bought this applications: greenfield projects and existing migration code base, or migrating existing code bases. Migrating an existing code base from a traditional layer cake approach to functional architecture is a tricky business, and I have notes with the makings from a whole slide deck on this. The TLDR, I don't recommend doing it all at once. Very briefly, an effective strategy can be reduced to a few steps. Examine the existing services and their use cases, and agree on a model of how they can be extended with new workflows rather than continuing to graft on new methods. Then we can start building out these workflows in such a way that we can all understand what they're doing and how they work. Eventually, we can begin migrating old use cases out of service classes when it makes sense, when we have a good sense of what we're doing. These two models can live side by side for a long time without too much trouble. What can cause some trouble, though, is multiple idioms of functional architecture living together. It's just harder to read and creates a lot more tech debt. That's why the modeling and planning step is so important. You don't have to plan a whole new initiative to get your feet wet, though. If you find yourself about to add another function to a 1,000-line service class, create a stealth workflow. Just don't go too nuts with the internal application events and the like. Just keep it simple and see who else gets excited. Then start some conversations. Greenfield operations, I mean, I'm not going to talk a whole lot about greenfield applications, but it's basically the same approach without the retrofitting. This is just took me 30 seconds to come up with this list. I'm pretty sure that most of us could do a better job than this given the opportunity. But the most important thing is this model hypothetical workflow, like decide how you're going to do functional architecture before you start doing it. Not the whole thing, but just agree on some things to try first. Either way, it's important, again, it's important to agree on a way before you implement it. This is the largest list of best practices. Even then, it's just a starting point. I could probably do a whole presentation on this slide. It'd be fun. Since we're working in Java, there are even a small handful of patterns. You've seen a couple of them that are useful, like using a factory pattern to generate implementations for mono.error. Blah, blah, blah. Each one of these principles is derived, oh God, yes. Each one of these is derived from real world experience. And it's entirely up to you whether to follow them. You'll inevitably discard some and add new ones as you gain more experience, and hopefully so will I. And so your initial agreement will also need to end up changing quite a bit. Who looks at last year's code and doesn't think, what was I thinking, right? So it'll change. Your understanding of how to do this will change. Mine has. Just be deliberate about how it changes. Probably less relevant to my company, but for the curious, the principles of functional architecture can be applied to many other languages. The main requirement is that language supports some version of higher order functions. We've seen here how Kotlin integrates seamlessly with WebFlux and makes functional architecture a little more readable on the JVM. Coroutines are also available as a more or less drop-in replacement for WebFlux. Go works very nicely as well, and Go routines are approach concurrency using communicating sequential processes just like coroutines, and spelled with a K or a C, and it's therefore more or less analogous to WebFlux. Other languages have their own abstractions you could theoretically use to implement workflows with varying degrees of difficulty. I suppose you could do it in C with function pointers. Maybe, I don't know, fun to try, right? For somebody. There are also a number of tools available to help you build out functional architecture projects. Spring Cloud Function is an officially supported Spring framework that provides some neat abstractions for composing functions. Initially developed as a way to interact with serverless providers like AWS, Lambda, or any of the other self-hosted alternatives. Personally, I found that it adds a little more overhead than it provides clarity, but possibly, again, with more experience, you could make it pretty effective. And finally, here's a number of articles, videos, and trainings I've found immensely helpful in digesting this information. I'll make this slide deck available through Slack, I imagine. If you have time to only look at 2 of these links, I suggest that you start with the article, A Primer on Functional Architecture, and the video Hits of Success, both by Mark Seaman. Any video on functional programming by Venkat Subramanian is worth watching. So how'd we do? Do you feel inspired? Do you know enough to ask more questions? I hope what you take away from this presentation is the motivation to at least, at least look into the possibility of applying this to your own projects. So that's it. I think I have time for a few questions. I'm hoping to schedule some follow-up discussion. Oh, that's from a different presentation. But yeah, please feel free to reach out to me with questions, or even just let me know how you're applying functional architecture to your own projects. Thank you very much for your time. I'm going to jump to the contact slide so that you can reach out. Questions?
Yeah, folks, if you have some questions for Jen, this is the time to ask those questions. I saw one, there was one question in the chat. I think, was it a question?
Oh, yeah, I see it. Why is a map a code smell in reactive programming? Yeah, right. So here's the deal. Not just a map. Maps are fine, but nested maps. I'll see if I can find that guy. Here's one. Because what you have here is with a map, which is theoretically a pure function, it's not as bad. But if you have a flat map and a flat map, what you're doing is building a fan out of your logic, right? And you're multiplying the amount of resources without a great deal of intentionality. It also makes it harder to read, harder to reason about, all of that thing. I have a question about, can I talk about logging in higher order functions? Does it make all functions impure? That's a really good question. I think, technically, I suppose it could. You could, so you're talking about using like the log4j thing. Technically, you're writing to a log file, right? You're writing to standard out. So yes, that is a side effect. But does it affect testing? Does it move it outside of this circle? There's a point to be made for that. Yeah, sure. But I would say it's a pretty rare case. And the ways that I would say that you're going to create the most notable side effect would be when you have a situation where your log goes away and your supposedly pure function starts to blow up because of the outside world. It's a reasonable concern. Is it a common thing that happens? Not very. Can you test for it? Absolutely. Any other questions on Slack or in the chat or out loud if you like?
Yeah, if you have some questions, you can also use can use Slack. And I will. I'm going to share the. I'm going to share the presentation video in Slack as well as on our meetup site. So, Jen, are you gonna also share the slide deck?
Yeah, totally. I'm gonna stop the recording.